for the last example in this lesson, I just want to go over a couple of weird situations that can arise and how we'd write the answers to some of these weird situations. So in this particular one, we have an absolute value is greater than 0. We can go through our normal three-step process here, and we start off by pretending like this is an equation. Absolute value of x plus 2 equals 0. Do we have an absolute value by itself on one side? Yes. Is the other side non-negative? Yes. 0 is not a negative number. Therefore, we can use the absolute value property, which tells us we can set x plus 2 to be equal to 0 or x plus 2 to equal negative 0. Well, negative 0 is just 0, so we just get the answer of negative 2 twice. Now, we're not going to actually identify it twice. We're going to say it's one number. So when we come over here to figure out what gets shaded, we only have negative 2 as our border point. Negative 2 has an open circle because our original inequality didn't have or equal to. So we do not want to include that point. Now, if we want to use the V method again, we absolutely can. We're supposed to draw a V that intersects our line at the solutions where we have drawn. So if I want to draw a V here, the way that we do that is the point of the V is right there. So now instead of the pattern we're used to of above, below, above, if we look at what's happening now, we only have two chunks we're looking at. The chunk on the left, the V is above. The chunk on the right, well, the V is also above. It's not below the line over there, it's above on both sides. So if we go back to the original problem and say, when is the V, well, greater than means above the horizontal line. Well, it's on both sides. It's on the left. It's on the right. Which means we have the interval on the left, which is from negative infinity to negative 2, but not including negative 2, as well as the interval from negative 2 to infinity. Now, in layman's terms, what's happening here is it's everything except negative 2, which should make sense, common sense, if we look back to the original problem and say, when's an absolute value going to be bigger than 0? Well, pretty much always, just as long as it's not equal to 0, because it's always either bigger than or equal to 0. So we have to write it in this way then to say the left chunk is one interval, but I can't continue on without lifting my pencil because negative 2 is not included. So then I have to list the right chunk by saying negative 2 to infinity. So that's one weird situation where there's a 0 on the other side. Here's another situation that's kind of weird as well, just in how we're going to write our answers, because so far all of our answers have had an infinite number of answers, and so we've listed it as an interval. Now on this one, step 1 is pretend like this is an equation. Do we have an absolute value by itself on one side? Yes. Is the other side non-negative? Yes. So we can use the absolute value property and break this up into two separate equations. And like before, we're going to get negative 2 for both. And so we only list it once. Looking back to the original inequality, though, this one has a closed circle because we were allowing equality. Now, like the last one, we would draw the V by just making the point of it hit there since we only had one solution. Like the last one, we only have two chunks, the chunk on the left and the chunk on the right. The V is above the line on the left, and the V is above the line on the right. So then we go back to the original problem and say, hey, what did we want? We wanted the V to be below the horizontal line. Where is it below? Never. So we're not going to shade the left and we're not going to shade the right. So looking at the number line then, what is our answer? Well, we have a dot at -2. That dot means x equals -2 is the only answer. We don't have an infinite number of answers. We only have one answer. So if we want to use symbols, we could use the brackets, or the braces rather. The braces with -2 is one way, or we can just simply write x equals -2. But we have a single number answer here. In common sense, if we go back to common sense here, we want to know when an absolute value is either going to be less than 0 or equal to 0. It's never going to be less than 0, but maybe it could be equal. And that's the point that we're allowing. We're allowing the point that where the absolute value is equal to 0, which happens at x equals -2 in this example.